So in the last exercise, we used exclusive OR. And exclusive OR kind of has some cool properties to it. One of the things that it can do is if we take something and then exclusive OR it against another value, we can use that value again and create the original value. And so essentially what this is it's a very primitive, basic example of symmetric encryption, where we use the same key to both encrypt and decrypt the message. Many times in this day and age, we use asymmetric encryption. For instance, if when I upload this to GitHub, what I'm using is an asymmetric encryption where we share keys and we use one key to encode and one key to decrypt. For this, though, we're using the same key to encode and decrypt, and so it's symmetric. I wouldn't recommend using this in any production, and really this is just an example. This is something that can very easily be attacked by even looking at a letter frequency distribution. So with that in mind, let's actually figure out what our password is here. The first thing that we need to do is load the byte array into memory. And so let's just put this in register 4 because that's where I like putting things first. Come down here, load register, and stir. And then even though we have the key defined here in a equal directive, we actually need to use it in some way. The cool thing about this is that, like a macro, what it'll do is it'll directly substitute it within the code. And so we don't actually have to load this 2014 into a register in order to use it. Because it's small enough we can use it as an immediate, we'll just do that. So let's start with the loop. And so what we're going to do is we're going to load the first byte, and we'll put that in register 5. Oh. And for this one, we know that the number of bytes that we write will be the same as the number of bytes that we read. And so let's just overwrite the bytes. We won't have another part of memory where we'll put the output. We'll just overwrite the memory for the input. So we won't increment here. The first thing we need to do is see if we have the end of the string as usual. And so we'll compare the red byte to 0. And if we do, we'll leave the loop. We'll use our exit label again. If it's not, what we're going to do is we're going to XOR the number that we read with our key. And so we do that with the EOR instruction, exclusive OR, same thing. And we'll store it back in R5, and we'll exclusive OR R5 and our key. And so you can see how we use the equal directive. We just write the what our variable is. And then what we want to do is we want to take the result of this and store it back into the byte array. And then increment it. And then that's all we really need to do for this. And so what we'll do is we'll read the byte, XOR it against our key, which is 214, and then store it in the place of the first one. Read the second byte, XOR it, store it in the place of the second one. After we're done doing all that, what we can do is we can use our null write and give it the label of our in string. This is another time where because I'm me, I would like to have a line ending, just so it looks a little bit cleaner when it actually gets outputted. You don't need to do this, but we'll do a line ending here too. And if you remember the last time, the way that we did it is we went here, we put the value, OOOA, which is the null byte and then the line ending. And then we're going to store this into the output string. Because we did a null write in that macro, we don't have a guarantee of what happened or didn't happen. We'll just really quickly here reload the address in case it did get overwritten. It shouldn't have because we're operating in the 4-5 range, but if it doesn't, this will just be a no op. And then we need to store these 2 bytes to the address. So we'll use store and then H for half word, which will do both bytes at the same time. So the address are 4. And then we'll just pass this off to null write again. Then after that, the only thing that we really need to do is set up the exit for the program. Again, in R7, we're going to put number 1 because 1 is exit. Our only parameter is R0 is our error code, and there's no error, so it'd be 0. And then SVC0 will issue the software interrupt. And that's all we really need to do for this one. So if we use our makefile, we run it, and we see that our password is hunter2.